outside of Moscow. Actually, it's 3+ years.
That's right.
That's right. And I can sort of empathize with that because I managed to spend 8 months out in Siberia in Novosibirsk. So I know something, yes, I know something about moving, and I also know something about moving far, and I know something about learning languages, and I know something about learning a language that is written in a different way, that has different kinds of characters. In this case, we have an alphabet here. And as you can see, Greg is going to talk about speeding up language learning, and I've looked at it, and I would think that if I had had it when I'd gone out there to learn some Russian and to learn the Cyrillic alphabet and to try and understand the words quicker and faster and be able to use them when I go out and I want to speak Russian, this would have been extremely helpful. So, Greg, your turn.
Very good, thank you. Good afternoon, everyone. So, Chris said I'm Gregory. I'm a software engineer and I come from France. For those who don't know France, it's a small country west of Germany where people are not very good at speaking languages. And as Chris said as well, as part of my career, I actually spent 3 years in Russia, which is, for those who don't know, a very big country east of Germany where people are even worse at speaking foreign languages than in France. So, obviously when I went there, I went to this small town, industrial town south of Moscow called Stupino. No one speaks English there outside of the office, so I had no choice but learn Russian. What I've noticed is that there are lots of applications to learn languages around, but actually none of them allow you to actually write. Usually you will type in the best case, sometimes you just pick and choose, but you don't have to actually write things. And when you learn a new alphabet, I find it very important for the learning process. So you just can't remove the writing part. So what I wanted to do with this application is to bridge this gap and give learners an opportunity to learn through writing. And this is what this presentation is going to be about. And I had other objectives as part of this presentation, which were to learn new techniques. So I came here to Berlin, a data science retreat, to learn. So I wanted to try new things. I didn't know neural networks before I came here. And also I wanted to try and give back something to the machine learning community. So there are a lot of free tools and data sets around which we use all the time, and I wanted to see if I can make a contribution to that as well. So let me start with the project. So any data science project needs data, so that's where I needed to start. And in my case, I needed letters. I needed to see lots of letters which I could use to train a machine learning algorithm. So I built this small project. I don't know if you heard of MNIST. It's a very famous data set in the machine learning world. And so I created my own version of MNIST, which I call COMNIST, or Circuit Oriented MNIST, in which basically I needed to crowdsource, because I didn't really know how to obtain the letters. So the first thing I did was design a website to crowdsource the letters, and I'm going to show it to you right now. It's very simple design. And the idea was just to ask people to draw letters for me. So go on this app and they're being asked to draw a V, so they draw a V and then they just click next, and then they have another letter. And so there were obviously two challenges. One was to capture the users and get them interested in this application, but then there was also a challenge of, once they are there, to keep them as long as possible. So I've added an element of gamification, so there are actually levels, and as I press next, I get rewarded by getting a new Russian car, and you can do that up to 125, you get new levels. So that was really the first step, and that's how I managed to capture a lot of data. Obviously, once I had this setup, I needed to promote it. So to promote it, I used several channels. I did present here at Berlin at PyData meetup, so some of them may have seen me over there. I've promoted on social networks. There is Contact here, which is the Russian equivalent of Facebook, forum Reddit. And so I captured my letters, and then I had to make sure I don't have too many wrong things in my data set. So I wanted quality, yeah? And so the best thing to do that was to implement anomaly detection. So I have this algorithm which I run on my data. It's based on statistics, which allow to remove data which are not correct. And so finally, I store that in GitHub. I've got my letters there. It's available for the community. I've made Creative Commons, so any data scientist, machine learner can go there and make use of it. And it's actually got Cyrillic and Latin, so you can use it for both Russian or any Latin language. Okay, so just in a few figures, I've started that 4 weeks ago, and in 4 weeks I managed to capture about 20,000 letters. I got contribution for 37 countries, but actually 3 of them were the most active, so Russia, Germany, and France, where I've got the most contacts and the most impact as a result. At some point I got really excited because I got users like doing huge number of letters. I can see as high as nearly 700. Actually it was my mom. But fair enough, I mean, thanks to her. And now I'm going to talk about a few challenges I had as capturing the letters. This is example of letters X's which I've captured on my website. And the thing is, if you look at the first two, they look really like X's. But then the next ones, you know, you're not sure whether you should accept them or not. And so what I did is really I kept that because the intention for the application down the line is to be able to recognize letters which are not canonical, you know, like even if kids use them or whatever new learner of the language use them, they're not perfect, it should be recognizable. Now I also had examples of letters which obviously I didn't want to keep. So the first three, I guess, were kids using without supervision. I had a lot of that actually. There were some which I don't dare showing, they were clearly vandalism, but okay. The good thing is that the anomaly detection managed to remove it, so that worked quite well. Also I had things which I wish I could keep, but I couldn't. So I had that in my data set, but I just ended up deleting it, unfortunately.
That was your mom.
That was not my mom, actually. Alright, so I talked to you about the data collection process, and now I want to talk about what I did with that. And so I moved on from this communist data set to what I call the Learn to Write engine. And so I started from my images, which I collected. And then I used a convolutional neural network to learn to read these letters and identify them. So in terms of technical stack, I've used Keras, which is runs on top of TensorFlow. It's really like the best tool around to do machine learning with neural networks. I was coding in Python and Flask for the HTTP server. And so I've got this engine, and I've wrapped it into Docker. So it can be basically used anywhere, and I stored it, I hosted it on Google Cloud. So it's now available, it's there, and anybody can actually go and use it. So if you want to build your own application to recognize Cyrillic or whatever other languages using Latin, you can actually do that. So once I had all this ready, the final step was just to build a small application to demo it. So I'm going to show you what the product looks like. So it's just like one example amongst many which you could use. So here is the idea. You can actually choose the language you want to write on. So we start with Russian here. The idea is that we've shown an image and need to recognize what it is on there. So in that case, this is a mask, and let's say I write it I make intentionally a mistake because in Russian mask is called maska, but the S is not drawn like that, it's drawn differently. So if I submit it, mouse. So what it tells me here is that I've made a mistake, right? So in this small application, it tells me, okay, you wrote it wrong, you've got one letter wrong. So I can actually retry, and this time I'm going to write properly. With a C which happens to be a S in Cyrillic. And if I submit it, a bit slow. Well, that's the risk of live demos, right?
That's the internet is so right?
Yeah, well, I have internet issues, so let me just maybe retry. Okay, then it worked, yeah. Just to give another example, now let's try in French, for instance. So, does anybody know how to say nose in French? Ne, right. So, let's say I misspell it and I write N-E. And what happens is that it's going to flag that basically I missed a letter because it turned out that ne is actually written N-E-Z. So if I write that and I submit it, then this time it's okay, it accepts it. So it's just an example of an application you can make based on my engine, but you could do much more obviously. In terms of performance, I've looked at what similar tools, commercial tools do, and the performance they claim is up to 99%, but what I like is the up to, because they tell you that in optimal circumstances they will find 99%, but in real life it's probably not as much. In terms of my neural network, I get 98 for Latin and 97, more than 97 for Cyrillic, which is not exactly as good as what they claim, but if you consider it, this is an example of letter I've captured from my communist application. So I asked someone to draw me an N, and what he drew is that. What do you think it looks like? Does it look like an N, or does it look like a W, right? So you could claim that because my dataset is clean, right, but it's not pure, it's not like as pure as letters printed. Well, you might have things like that where sometimes it makes error in predicting, but maybe it's right actually, because that looks definitely to me more like a W than an N. And what I've done, just to improve it, the thing is, with neural network, they don't predict a letter, they actually predict percentage for letters. So when I ran it through, it told me, well, I think it's a W with 45% accuracy, and I think it's an N with 40% accuracy. And then it predicted other letters with lower accuracy. So what I can do is, when I recognize the images, I can say, okay, if it's a W or an N, let's accept it. Let's not break and say the user he made a mistake. Let's accept it because maybe it's a W, but maybe actually it's an N, I'm not sure. And that leads to actually results which are kind of state of the art and which are really good. But just to conclude, it was really an exciting project. I learned a lot. It leads to concrete results with this data set which I make available as well as this API. I had my contribution to the data science community. And it had me build my network in Berlin in the machine learning community because I presented at PyData and people started recognizing me and talking to me, and that was really enjoyable. And in terms of next steps, I'm building partnerships. So I'm in contact with SPACAT, which is a Russian learning school that are interested in the project, so we can develop it and build more content into it to teach Cyrillic. And also in partnership with RiseML, which are going to be hosting it, so it's a startup Berlin-based. And potentially, well, I could extend it to more alphabets. But I need volunteers to draw more letters. And that is it for now. So if you have any questions, I'll be glad to answer them.
So, questions, please. Over there. Yes.
How did you do the segmentation? If you recognize it?
Yeah. So I didn't mention it, but that was one of the issues. I've got that here. That's probably the thing which I need to work on now to improve the engine, because today the segmentation requires letters to be well separated, which means you need to have a white line between them. So in that case, because there is a bit of overlap somehow, it breaks. Yeah. So that's something I need to work on still.
Another question, please? Yes.
The convolutional network that you use, could you briefly describe that? Like what kind of, can you use dropout?
Yeah, so it's a convolutional neural network with 3 convolutions. You have the convolution and then ReLU, convolution and ReLU, and max pool. And then you've got again convolution and ReLU and max pool. And then you've got 3 times fully connected layers. So it's pretty big at the end. I don't know if you want to get into more detail.
Oh, we can do that.
Yeah, sure, with pleasure. Okay. But the thing is, the training was relatively fast. So GPU engine, 20,000 letters. It takes about 2 seconds per epoch, 200 seconds. So it doesn't take very long actually once you've got the right architecture to train your neural network in that case. And prediction, as you can see, it's instantaneous.
Okay. A question at the back? No? Okay, then you go first.
Quick question. How many input neurons you have in the first layer? So how many pixels do you input in the network?
Yeah, so it's 32 by 32. So I'll let you do the math because now you just. So yeah.
Okay, one more at the back.
Do you deal with rotation and robustness?
Yeah, so as part of the training, I used Keras as some data augmentation mechanism, which will do a little bit of translation, of rotation, zoom in, zoom out. So I've used that to fight overfitting and to make it more robust.
Okay, I think there was a question here in the middle.
No, no, no.
You
Answers.
answered, okay, then you wanted?
I mean, you said you use convoluted neural networks. Did you try any much simpler methods, logistic regression, whatever?
We tried that on, as part of the learning process, we tried that on the MDs, so on the 10 digits, right? But it didn't lead to results as good. I didn't try for comparison here, but I mean, we know by experience that the more classes you have, the more complex. So if it leads to better results, like neural network on 10 classes, obviously on 26 or 33 classes, neural networks may be much superior as well.
Well, I'm not sure that I would agree, but.
Okay, a final question? Okay, thank you, Greg.